So let's jump into it. Most of you probably have heard about this test-driven development, where it's actually a software approach where you actually, before you start coding anything, you begin to create the test cases to test your code. So what you're actually doing is you create like some kind of skeleton or like a framework, and you put a lot of stup methods where you just implement no code at all. You just make that this is a function or this is a method, and whenever I call it, it has to do some logic. Afterwards, the project goes further. You will actually begin to implement the code, and at the beginning, everything is going to fail. But whenever you go closer to the deadline or the end of the project, everything is going to begin to actually succeed. So one of the things about test cases is that if a test case has to give sense, it has to map one-to-one directly to a use case. Else, probably the test case doesn't give sense at all. But it's very easy to like get a use case described by some business people, and it's very easy to make a test case in code. Well, easy. We'll see into that in a bit. So, what is it? What we actually see in this kind of approach? Well, a lot of business experts actually produce a lot of documents, and they can be both Word documents or whatever text editor. They're able to write whatever they want to tell or want to explain how the business logic is going to do. And sometimes that's not enough, so they have to rely on diagrams just to probably explain a bit more. And I think it's like Microsoft what's called requirements, where they actually have this sentence that a picture actually tells more than 20,000 or 1,024 words. Like, what is it like to the power of something? So what happens once the business experts have written all this in plain text? They actually give those documents to developers, and most of the time this kind of documentation is created by people working at a place, and then software suppliers actually taken in developers to read these documents and then make the software based on the documentation. So what happens most of the time is that most of the developers don't have any clue of the domain they're actually going to work in. So you've probably seen a lot of those diagrams where like people are very unproductive at the beginning of a project, and just at the end it begins to peak because developers begin to understand the domain which they're actually coding in, and they're actually able afterwards to probably fix some bugs or fix some bugs that shouldn't be there in the first place. So a few pros and cons to this approach. Like the first one is that business experts are actually able to describe what they want for the application in plain English. That's one of the great things about that. I would say that one of the bad things about that is that it's whatever they produce, it's not to be read by a computer. It's to be read by humans. And based on the approach you have, it's probably good or bad. But from my point of view, it's actually bad, because all the hard work they put into this description on how to, or for how to the application to work, it's more or less useless unless it gets represented as code, right? Also, this with the software documents is that at some point, the business people, when they deliver this documentation, they go to another place and do other stuff. And the developers create the initial phase of the first iteration of the application. And then they come the second, because as everything, software actually changes with the life cycle there is. There's no application that's going to be the same thing forever. So what happens is that sometimes, or I would say most times, the initial documentation doesn't get updated. And you have like a very like documentation, or like how the software is built, or sorry, how the software should work compared to what's actually happening in this application. So we see that a lot, especially in the consultancy world, where you have to take something and upgrade it. So what you get is the initial documentation, and you write like some kind of analysis about this on how to upgrade it. But what you're actually trying to upgrade is not that. So this is one of the things that's also bad. And I'm going to put here like a small star, is that an industry where this cannot happen is the medicinal industry. Like, it's a legal requirement that you have to always update the documentation based on what you have coded. But the problem with this approach is very, very slow. So before you can push something into production, it has to go through a lot of stages. But again, I think it's okay because it's actually like human lives, which is on the line. So of course it goes a bit slower, but it's more safe to do it that way, right? So again, I think the main issue here is that we don't have any kind of binding between these two layers. Like, people work on one place, they do a lot of nice stuff, and developers on the other side do a lot of stuff in the other way. So again, developers don't know the domain, and business people don't know how to code. So it's like this misconception: we don't know what you do, and you don't know what we do. And again, depending on how complex the project is and how, what can you see, complex the software provider is, like, you're probably not allowed to talk to the guy who knows what it is. You have to go for several layers, because you have to talk with his manager, we have to talk to his manager, and have to go down and up and down. So what happens is, like, I don't know if you remember from primary school, is that if I say something, I whisper to Simon here, and it goes all the way around. Whatever I say to Simon is going to say, you're going to probably say something totally different, right? So this is what we actually see a lot in software development. And you can talk about we do scrumming or all the new agile methods to do this thing, but we still have this, I would say, big gap between business and development. So I was trying to look after a picture of a school class, but don't search for this on a workplace, because I was getting some strange, not suited for work pictures. So there was a bit. So I found an old one from 1955. So what the fuck did you just say? Yeah, I don't know. So what I will try to talk a bit about is this type-driven development, or domain-driven development is. Sorry, I have a bit of a cough. But the thing here is that, how do we actually introduce people who write these documents, people who are actually experts in these domains? They have been working with the same thing probably 10, 20 years. They actually know what they have to do. So I don't know if any of you know this company in the States called Jane Street. You know it? So it's a financial, we can say, company that actually builds software to what was called trade on stock markets. And what they do is that they actually take stockbrokers and they pair them together with a developer. So that's the first thing they do when they hire people. So a stockbroker have to talk to a developer, telling him, okay, so how do you actually work in this domain? And the developer have to talk to him, to the stockbroker. Okay, so when we code, we actually try to represent this in this ways, on these different paradigms. So what Jane Street does is that they use this programming language called OCaml, which is like very, you can say it's a functional programming language, but it's very, very similar to mathematics. So a lot of those stockbrokers have really good knowledge about mathematics, and they're able to actually see very easily what's the developers doing. And the developers, because he begins to understand what they're doing, he's beginning to understand what the domain is. He's really like able to code whatever the stockbrokers is able to say. So at some point, the stockbroker, he's able to code with this language. And I just want to put here, like I say, the use of OCaml. So initially, F# in the .NET world was actually done trying to port OCaml into the .NET ecosystem. And I know it's been recorded, so I don't know if it's okay to say it, but that way. But that's actually how it got born into the .NET environment. Now they're very, very similar, but they're actually different, because they still have more or less the same paradigm, but they went two different or separate paths. Like OCaml doesn't have parallelism, and F# has, and OCaml have module functors which F# doesn't have. So they have some different things which make the languages really, really cool on their own. So this pair programming, and if you actually go to the website and zoom really, really in, not too much here, but here you can actually see that this is F# code. A broker with a developer, they're actually looking into the screens, and you can see where they're trading and doing this small pieces of code. So this is actually an example. I gave a talk for Office 365 Saturday in Copenhagen a few months ago. And I tried to, actually made an application based on SharePoint which communicated with CRM. So just for telling what was going on in this travel application, I did like the traditional with where we do like this diagram on the initial part with some text, and then I made also this domain modeling. So I'm not going to tell you what the application does, because we're going to look into this diagram first, and after we're going to look into this domain model. So here we have all seen an entity relationship diagram, right? So what we can see here, like, there's a reason I put it in the middle, but we can see that the centric of the domain is a booking. So it gives sense that a travel company, a travel agency company has a product or some kind of products where you have to do some booking. And if we look into this, we know that because we have at least one element, we know that before I can do some booking, I need like a plane or a plane ticket. So of course it gives sense, I'm going to some place, I will need a plane for that. Then we can also see that we're probably able to have one hotel or not, or we're also probably going to rent a car or not. So this is probably what we can read out of this document. And as I state here is that if I will need more information about what I'm seeing here, I probably have to go to read some text produced by a business expert, right? But, sorry. So which kind of product are actually being offered by this company? Like I say, I need to read more text. So, oh, the color, you can read it, right? It's not too dark to see. So here, I'm trying to do some domain description here. So if we just abstract away from all these initial keywords, my system actually has a booking which equals, so we all more or less have coded here, right? So let's just think about this as an OR operator. So my booking can actually be of the type basic, and we need a plane for that, as we saw before. Or it can be some combo of the type combo, we don't know what that is yet. Or it can be the full pack, where we actually have to take a plane, a hotel, and a car. So plane information is, of course, I would like to know when I go out and when I come back. And that's just the date and time, right? We will like to know when we have to be at the airport and with time, and we would like to know when we come back with time and also with date. And, sorry, a bit of a cough. We would like to know to which country we actually go into, right? The combo thing I mentioned up here. So we had this thing we saw before. We have like with a hotel, which is just a plane and a hotel. And then we have the other one with a car, which is just a plane and a car. A hotel is just whenever you arrive, again, a date time specification, the departure, again, date time, and again, the location, which should be more or less the same destination country. And car and country as well, which we just limit to an ISO code. So this gives me a bit more of an understanding what is actually happening in this domain I'm actually going to work at. And this is probably English, so God damn it, it doesn't work. So yeah, so I'm able to get a bit more of information here. And already here we can see some constraints if we look clearly. So if you just think of this symbol would just be like a tuple or a pair or triple. So here we have like a triple. In order to get full pack, of course we have to take the plane, the hotel, and the car. So this is like a triple. If we miss this one, we will actually go down to the tuple. where we have like a with hotel or with a car. And if we go away from that one, we will end up with a plane. So this is more already the constraints that we actually build into the domain. Yeah. And the other one, just before skipping this one, is like, again, if you just think again as a tuple, like again, we have a plane, just for the sake of readability, we just put some labeling. So, because if you just created here a tuple, if you say daytime, and country, it probably wouldn't give that much of sense, because is the first element in this tuple like when we're outgoing or when we're returning. So sometimes it will give sense to put on this tuple like a label, so we have a better understanding. So when I prepared these slides, I actually had somebody to read them through like the draft, just to come with some feedback. And the feedback I got was, hey, I thought you were going to give a technical talk. Where's the code? So yeah, what I was showing is actually code. This is something that is very similar to English. And the only thing you need to do is that you need to understand this few concepts. So in other languages, which is in the same family of ML, probably here instead of saying type, they say data, which gives a bit more sense. Okay, so if you have some data in the system where booking is this, and that. But if you just like, this is not a whole new language we need to teach people. This is still plain English, but we can just teach these few keywords and just explain them to people to what is actually the meaning under this. And I have learned to speak like Italian, I speak Spanish, I speak Galician, I speak Danish, of course I speak English. So we're able to learn a lot of languages, and we don't need to invest too much time in have this understanding. So what is one of the really cool things about this is that we actually write the domain specification of an application in something that's very, very similar to English, and we can actually teach business experts to do this, just like the guys from Jane Street does. One of the really good things is that the functional programming language, both OCaml and F# have this thing called algebraic data structures. So it's record types and sum types. So just to give you a small definition or a small understanding of what a product type is, just think about it as tuples. So this is what you actually put, like what I've shown before. So this is just a tuple, again, with labels, as I say before, like this wouldn't give too much sense, but if we put a label before, we will actually understand what's actually happened with this tuple. And again, with the sum type, a sum type is just like a disjoint set. So it's more or less to say, oh, it's something in this set, or it's something in this other set, or it's something in this other set. And all the elements that are actually the same in those sets will actually combine to the same. So that's why it's a disjoint set. But because we use this algebraic data types which come from mathematics, we're actually able to use mathematics to ensure constraints. So we're actually able to say that instead of creating a lot of test cases in order to test the application, we're actually able to tell the domain, we don't allow you to make all these other things that can go wrong, as we have probably in some other kinds of programming languages or paradigms. So this is like a statement that is used by the CTO of Jane Street, which is, he says that we're able to make illegal states unrepresentable. And that reduces hugely the amount of test cases. And I found actually a small bug. It probably don't give a sense to fly to a country, because if you fly to the States, it's not the same flying to California to flying to New York. So I actually changed it to city. I think that gives a bit more sense. So even though you make these claims about, ooh, the domain actually ensures everything, if you misunderstand the domain or misunderstand with naming or, I don't know, with conventions, you're actually going to code wrongly. So we're never 100% safe. And again, like, we have to be really careful with this you will always hear like the functional guys coming, oh, well, yeah, just use some kind of functional language and everything is going to be all right, everything is going to be cool. That's not always that's not always the case. So I'm a huge fan of Jaron Minsky, CTO of Jane Street, and Richard Feldman, which is, I think it's No Red Ink, where even the guy who makes Elm is actually working right now. They have this kind of statement, and of course they argue why they come with the statements. But again, we need to be very careful that it's not, if you do it like this, don't ever test again your code. No. You still need to test, but you just need to test fewer test cases. So one of these things that I discover while doing this is that we're able to argue about states. So we're actually able to say, okay, so the state representation of the application with this kind of constraints, we actually ensure that it can be compliant with this mathematical constraints with the algebraic data structures. But what happens when we begin to introduce state transitions? So ASCII art for the win. I put some plus symbols here for the state, which is more or less what we have seen into now with this travel agency app. And then we have like the transitions. So if I have a switch here, I can turn it on. Or so if it's turned on, I can turn it off. And then we'll be in a turn off state, and I can turn it on. And then we loop to infinity, right? So what you see a lot of people is that, well, this is more or less the normal approach. So what you create is a discriminated union, a sum type, which I say before, where the state can be either on and off. This is the only thing that gets modeled into this type system, to the type domain of this application. So again, just because we do this, it doesn't mean that we cannot do wrongly application here. So what happened here in this transition, I actually made a function that goes from on to on and then goes from off to on. This is actually something I did on purpose because nobody tells me that this function needs to comply with some kind of type definition. So there's a really cool tool in F# called fscheck, which is able to actually randomly test a lot of make a lot of test cases based on the domain you do, and this is where you actually catch this kind of errors. So what I did, I just fixed it, and I say, of course, you go from on to off, and then you go from off to on. But there is like, and this is probably getting a bit too deep or too dark into this, but it's just like to show that when you actually combine state, transition, and states, you actually end up with a state machine. And if you remember like regular expression, they actually come from a state machine. So you can see you start with here like a letter and you begin to search for another letter and then you go back and forth, back and forth. So by using like TDD approach to represent the state machine about opening a door, also turning on a light switch and then turning it off, I have to introduce these three very simple, what can you say, types in F# or OCaml. So the first one is it's a phantom type, and if you just think about a generic definition where you say that, let's just think about C# where you say this function generic of type T equals some other type. But what you don't do, you don't take the type on the other side. You let it only on the left side. This is a trick, well, I will show in a bit, which is really, really nice to do. The other one is just a function type, and just think about this. This is a lambda. So from some generic type T, we go from input into the lambda and then to the output of the lambda. So identity function is just like we go from A to A. We don't do anything with this initial value. So this is very concept in function. And then, sorry, then we have this other one, which is like not accessible, some type case constructors. And this is a way to ensure that you're able to have my type in your whole application, but you cannot instantiate my type. Only my module is able to instantiate this type. So what God damn it, it's dark. So what you have here is if you just think about this in a C# context, so module light will just be a static class. So we have a static class, and then we have a switch, which is a static class inside a static class. Yeah, you're allowed to do that. But on the parent static class, we have this phantom type, as I mentioned before, that we have this generic T type, and I actually make, if you just take this one like this, so I have the generic T, and take it on the other side on the type. And besides that, I make it private. So this is where I hide the constructor of this type. By doing this, all the code that is inside the module, or in the static class and the sub-static class, are able actually to call this constructor. But when you call my module, or you instantiate, or you call my static class, you're not able to create a switch. So the next thing I do is I create two types, or two, it's better to call them types. So the first one is turned on. It gives sense that the state is actually turned on. So I take my onType, or onTerm, and I combine it with my switch. Then again, take turn off, and I combine it with my term, and I combine it with a switch. I'm allowed to do this because we're inside the module, and I have access to this constructor. Now I use my type function definitions. So just think it as lambdas. So what I do in my lambdas, I say my input value has to be turned off. It has to be this one. And I will always return turn on. And the other one I do is, okay, I want to turn off. So my initial state has to be turned on before I can turn it off. So what I've done here is that I actually be able to represent everything as a type. The whole constraint of this small application is now built into types. I don't rely on functions anymore. Like here, it's very basic, but I'm able in my functions to make mistakes because I don't really understand how the domain is built. But what I do here is that I actually constrain everything into my domain, make it type safe. And here, you just see I have made two private methods or functions. Just think of methods if it gives more sense with a static class. And those are also private, so nobody outside can call it. And I don't do anything. So I have an initial helper, and I have initial helper, and then I have a turn on helper. So you can see that the only thing I do is I just return a state. Nothing at all. I don't do anything at all. And the other one, I just take a lambda, and I don't really care about the input value. I just return in the state as well. So this is actually very simplistic code. You cannot do this wrong because you just need to do this one. So now the public function or the public methods which you can call is turn on, which is just calling this one, and turn off, which just call this one. Oh, sorry, init on and init off. This is just to instantiate your application. And then you have turn on, which is just turn helper and turn helper. So this is actually, this is the piece of implementation code. There's no way you can get this wrong. You just call the same thing every time, but what you do is you just mark your types based on your type domain. So actually, this is a very trivial implementation, like there's nothing that can go wrong because we have ensured that everything is turned into the type system. Finally, it would be nice to see like the actual states of your application. So what I have done is, it's a bit tricky. You need to extract this generic type from your switch, and you can do that with some reflection. So reflection in .NET is a bit slower than most of compile functions, but again, you're probably just going to do it at the end. So I've done a lot of turn on, turn on, turn on, turn on. It's time to run. Okay. Nice. So, yeah. So how is this actually working? I import or use my static class called light. I instantiate my value to on. I just call the switch from my light switch init on. And from my init on, I can go to my, from my initial state of off, I can go to my initial state of on. and then I can go from off when I'm on, and then I can go back to off. Actually here I will get a compile error because I'm off and I want to go to off. So this is actually important, that if you really want to ensure that the states that you go from your applications need to be consistent with what you're doing. And let's talk again, medicinal industry. You really need to know what you're doing. So you can actually have this approach, because the compiler is going to say, no, computer says no, like, what is it, like Britain something. But the thing is, like, you're not going to be able to release software that doesn't complain with your domain. And the same thing about on and off. You cannot compare those two types because they're not the same, even though it can go from one type to the other type. And finally, you can output the state, and I don't think I have the... Yeah. So you can output the on, and you can output the off, so you can see what is actually the state of the light switch in that given time. So this is type-driven development. Let's talk about how do we actually ensure that all this fancy thing we do in this programming language is actually stored consistent in some data structures. So I was reading a blog post, really well reading, about event-driven design. Really well written. But the person doing it, he just made like the event store with this kind of approach, which is like you're able to use the object-oriented paradigm in F#. And this gives sense. We have like an an internal stage, which is just like a resize array, which you can make, which is of the type string, and a scout event. And then you have like members or methods in C# where you can save it or you can get it. So what happens when you actually use the object-oriented approach in C# in F#, is that you actually take the nature of F#, which is mainly built on the functional paradigm, and you actually have to make people think the other way around, like we used to in C#. I really like when I want to code on object-oriented or imperative, I like to use C#. But if I want to do like some functional programming language, some functional programming, I actually use F#. And the good thing about the .NET ecosystem is that you can combine the projects. So I think we should keep like what's great for one language in that language and what's great for the other language in the other language, and then use them on what gives more sense. So what happened here with the resize array, if we look back a second, we can see that it just called collection and it's just a generic list. So we allocate something in the heap, we add elements, and that just keeps growing. So now, I don't know, I just downloaded your module, and I would like to call your data structure as I would do with all the other data structures that are in F#. So I instantiated the resize array, and this resize array, because it's cool to, or it's very easy to use parallelism in F#, I just, instead of saying array.init, I just called it with parallel, and I just add a lot of elements into this array. I add 1,000 elements, and the thing I do is just I add the index of that initial value into the array. I then reduce it, so this is just a map reduce thing where I do a lot of things parallel, and then I just compress everything down to one value. If I run it a couple of times, I can see that it never gives the same value. So it's not deterministic, and it's also not correct, because if I put all the numbers together, it doesn't give this result. So what is actually happening here is, the thing is, if you go into MSDN, and if you've been working with .NET and C#, you know that most of the data structures, they're actually not thread safe. And Microsoft, on every single class, they write at the bottom, thread safety. No, it's not. So you're actually guilty if you do it like this way. So you have to do your own mutix, you have to log, you have to synchronize the values. And a lot of people say, yeah, but you just do a few writes. Yeah. But even though you do few writes, you still need to ensure that before you're reading, you need to log and then unlock. So that's where probably you lose a lot of the performance increase you can get of parallelism, because you have to handle with all this locking and unlocking and synchronization or synchronizing. So this is why I come with this claim that object-oriented data structures don't fit well with this mindset of immutable data structures that we have in F#. And that's why you're probably able to achieve the same if you use like idiomatic data structures, as I call them, and that's the name they have. So again, in this case, immutable, every time I write module, just think about it as a static class in C#, where you just add a lot of internal definitions. So here I have an internal class or type inside this static class, and as before, I just call it, or I just ensure that nobody can instantiate my type outside my immutable static class. So what I do is I just say we have a type T, and this type T is just a standard array. Why should I code everything from start or from scratch again? Hey, the guys from F# have done arrays, and they're not immutable, but hey, they have a lot of nice methods which I can just reuse. So what I do is I just say immutable, I define an internal array, and the only thing I do is I just wrap and unwrap. So every time I expose my underlying data type, I just do it with this phantom type or single case hidden constructor. So you can see my type, but you cannot instantiate it. And this is what I'm doing. So I just wrap it, take it out, and then I wrap it in, take it out, then I wrap it in, take it out, wrap it in. And I just reuse everything that is inside the .NET framework. So this is very easy. So what I actually achieve with this approach is, because I'm never exposing this underlying thing that's actually mutable, I can actually warranty, or I can actually argue, hey, don't be too cocky on this one, but I'm actually able to argue about the soundness of this data structure, and I can probably say that it's as safe to use as all the other data structures that are actually in all the other F# data structures that are natively in the .NET environment or F# core. So this not acceptable sum types case constructors, other languages as Haskell and Elm, which I also use, you're able to, when you define your modules, you can say what you want to expose and what you don't want to expose. So you can say that you can see my type, but I don't want to expose the type constructor. So it's more or less the same way of doing things, but it's just like other kind of wording. So again, this is just basic F# map reduce, instantiate 1000, and the index value with the identity value, just put it in this 1000 array, and then just reduce it to one value, and we can see that 499,500. This is the value we should aim for. This is the one where I use the object-oriented data structure again. A whole new value, 304,641. We shouldn't go with that one. And this is where I use my immutable data structure. So I just say, whenever I instantiate it, I just make an immutable array of one element. Then I just combine all my immutable arrays. And finally, so this is map, and reduce. Even though here it says reduce, I'm just mapping. I don't have the time, but you have to understand that this is how the underlying architecture works. So an array, because the values always need to be besides each other, it's actually going to allocate memory every single time you do something. So whenever I combine two arrays, it has to find place in memory where I can allocate 500 elements, I can allocate 1000 elements. So this is not like the list, where the list just append a new value every single time. But again, I'd rather go a bit more slow than go erroneous. So this is a reference to John Carmack, and he has this really nice, he's actually quoting this guy, which works in from the airplane industry, and he says, Henry Spencer, there's never went a single line to production that didn't work as they expected. And I, as a guy who flies a lot, I really appreciate that one. Like, that's something, hey, thank you very much, Henry Spencer, and the rest of the guys who are actually doing this. But as John Carmack says, hey, in the aerospace industry and the plane industry, what's happening there, it shouldn't be emulated by everyone. Just imagine, hey, we need to make this new CMS system or new website for this bakery that's selling bread. You probably shouldn't go as far as those guys, right? Because you probably deliver the website in 20 years. So the thing is, like he says, that sometimes they go to madness with all this insurance of things that shouldn't go wrong, but you end up with this snail pace. And to people not knowing John Carmack, I think everybody knows him. He has done some nice games. So, but the thing is, with this kind of approach I just showed you today, what if we were able to develop as careful as those guys, but fast, not having to compromise with all this insanity they go through just to ensure that the single piece of work works. So let the domain experts, the guys who have been working with this business several years, let those guys try to read or write in some kind of plain English, something that they understand, with a bit of mathematics, because we want to ensure that this domain, if we can get it as small as possible and the constraints right, then based on that information, we just need, as developers, just to implement. And if we can get it even further, where we can make almost the implementation, we can say, trivial for the developers, we're actually going in a step that is careful and correct, but fast. So this is more or less my point of this whole talk. And now is like the downside, because all this nice wording about this languages and all that stuff. So what happened is that sometimes you use something that you think that's really, really cool, but you put it aside because it's a small hobby project, and then you have to give a talk, and then you try it out again, but people have made some modifications, so what you did before doesn't work now, and you begin to try it out again. So what I discovered was that I would really like to show some WebSocket, where I have a WebSocket server, and I will make a lot of clients just trying to connect to this WebSocket. And probably have to do more with me. So when I started my company, I decided I want to go back to my roots, play a little bit with Linux. So bye-bye Microsoft PC, and welcome back Linux PC. So WebSocket's client in the .NET ecosystem doesn't even work for Windows 7. It doesn't even work for Server 2008. It just works for Windows 8, Windows 10, and Windows Server 2012, and probably 2014, if there's anything called like that. But the thing is, I'm not thinking it's going to work on Linux, and as I discovered, it doesn't work on Linux. So both MSDN and Xamarin tells me that, but hey, that's the thing I learned. So just to summarize up, and we go into some Q&A and probably some beers and pizza. So I just wanted to show this test versus type or domain-driven development, and make illegal states unrepresentable. Now you know what the second part of my company is about. State machines, I actually show how we can actually go very, very deep, but you have to think very, very careful in doing this. So again, Jane Street guys, the domain experts, sits with a developer, and those two guys together will actually be able to come to this one. I don't think the business expert alone will be able to domain model like that, and I don't think the developer will be able to do that. It has to be a combination of both knowledge domains. Idiomatic data structures, we try to do everything here very sound, but let's use something that doesn't make us lose all this soundness that we try to achieve with this approach. And just this is going to be my punchline. What if we were able to develop carefully, medicinal industry, aerospace, planes, whatever, but fast? What if we were able to combine the best of both worlds? And an example of that, it's the Jane Street guys. No code, sorry, I can show you something, but it's too dark to see, probably. It's not because I didn't code, don't worry. I'm not a bullshitter. So this is just, this is the server, and let's see if you can see this one. So with about, oh, this is too dark. Sorry? Yeah, about 91 lines, yeah. And this is built on something called Suave.io. The guy is Portuguese, so I know how to pronounce it. It's this asynchronous server, which is very similar to Phoenix, if you know that one, or it's based on an actual model. I wouldn't say that's similar to Erlang, but I think it's more similar to Phoenix, which is built on Elixir, another language which is built on Erlang, so everything just goes around and everything's just copied from another. So this is a really cool one where you just, with very few lines of code, are able to create a server. It can be a web server, it can be a WebSocket server, which receives messages asynchronously. So this is really like cool stuff. This works, but the thing that doesn't work is my multi-socket. And you can see some Elm. I almost made myself code in Elm, but we are in the .NET user group, so another time I probably give you a talk on that one. So I tried, but it crashes with some strange messaging. Any questions? Are you sleeping or? Yes.
The argument that you cannot make mistakes, I mean, that with the lines switch, you could still make the same mistake in your, you have more lines of code than the original example. Like here, you could say that turn off goes directly to turn off, right?
Yeah, yeah.
When you prepare the code.
Yes.
And so you model the domain, you know. But then you still have to have a test to find that mistake.
But the good thing about this one is, let's say that this is a small implementation and I have somewhere down in some obscure place. This is an implementation. This one, everybody looking into my domain will find that error. Everybody. So this is just a way that if you can abstract everything, just make high abstraction of everything. If you can get it as high up as possible, it's easier to discover errors. And the thing about this one, this will be us, the coders, and this will be the domain experts. Those guys know exactly what they're doing. So we can make them write this one. Of course, if they do, like turn on goes from turn on to turn on, it's their problem. It's their responsibility. It's not the developer's responsibility. So that's where I'm also trying to. No, it's like it's not a blame game. It's like you're really good at what you're doing as a business expert. Okay, so whatever you do, I trust you, and I'm really good at this one. So whatever I do, I trust you. Please argue with me what you're doing, and I will try to argue with you what I'm doing. So it's not like separate. We talk about what we're doing. Of course, I will see probably easily if the domain is not too complex that this gives a problem here, and you probably see, hey, what the heck you instantiating like the turn on? Why are you not? Sorry, if I just switch the function here. So I just called different function this one, but again I have it like marked with a type, so it would be very difficult to break this domain. But the thing is like what I'm trying to do is that all the hard work that business experts put into software development, let's use it. in the software. Let's not produce the most insane and awesome documents that are going to put into a box whenever we finish the analysis, and then jump into coding and find all the things that we missed, or that we actually missed under this analysis, and trying to define everything on and on again. The good thing about have everything in your domain is if I modify a single comma, make something changes here, everything that depends on this domain, it changes. So medicinal industry, they change this one. Every single piece of code that looks into that type needs to be changed. And again, because their documentation is here, they don't need to go back into their documents, find them the newest version, and then write all the stuff that they just did. We should be able to probably create Word documents based on this information, if they want them, if it's a legal requirement. But I think that's the right approach, to take something that's understandable both for developers and business experts, and then generate all the outcomes. Any more questions? So, as it was before in times, you will hear that it was just like very specific, like financial or mostly mathematics. The thing about C# is like it's a multi-purpose language. So, of course, C# you can use it for everything except web development. I rather go with HTML5 and probably some JavaScript or TypeScript doing that part. But if I have to do some backend in C#, I'd probably be able to do many things. And the same with F#. I know they're doing some F# to JavaScript transpilers, but again, it's never going to be the same as it is working with a language. So let's say on the front end, use TypeScript. Please use Elm or use JavaScript with Flow, Facebook Flow static typing. That's really cool. And on the back end, it's up to you. Like again, if you're going to use the paradigm of object-oriented, where you have limited amount of memory, where you have to rewrite a lot of stuff, but you probably just go with the C# because you're able to transform the memory placement with the new information that you're actually doing. But if you have a lot of memory and you have a lot of and you have to do a lot of parallelism, and you don't want to do all this mutisk logging, just use F# or OCaml or Haskell or wherever you want to do, Erlang, Elixir. There's so many possibilities nowadays, and don't use the last ones because it's the net user group. So use C# and F#. Nah. Yes. You have one? Yeah. You can just go back. This one. So. Yeah. So this is what I'm saying. That is, whenever we see these pipes, just think as the OR operator. So I have a booking of this one, or this other thing. This is what I have with combo. So my combo is of this. So I can have nested sum types. So I'll have a booking of a combo where a combo is a combo of the type with hotel and with car. So the thing is, you always say it's going to radix sort. You have a lot of buckets. So this is what you use in the postal service. So you have something that goes to Malmö, which is this big bucket. And when I go into Malmö, this is the zip code for this region, and this is the zip code for this region. If I go into Copenhagen, you have this huge bucket, but I have some smaller buckets. So this is where I live in Valby, or 2,500, and this is Hellerup, 2,900. So you just go in your bucket and you jump into sub-buckets. This one doesn't have a sub-bucket, so I can go into this and just end here. This one I can go into this sub-bucket and can go into this one. So you just do some nested bucket thing. Yeah. Again, it's we probably achieving the same thing, right? But it's just like how I saw the domain modeling in my head, and I don't know how a travel agency works, but this is the way that gives sense for me, because I would like to say how many combos did I sell. So I know that if I choose one of this one, it's going to be a combo. But if I put those two up here, I will have to probably do some other kind of function that I need to specify, because the 4 values, this one, this one, this one, and this one, would be the same kind of producting. But I would like to say, oh, this one goes to Copenhagen, this one goes to Malmö, but I specify deeper down, oh, so this goes to this region of Malmö and this other region of Malmö. But again, it's just how I domain model it, but it's a valid point to do it the way you say. So if Sharp, I don't think Camel has it, probably has it, but when you set like this 2 marks in front, you can write anything you want. And this makes it really, really cool, because there's some Unicodes. You can write some Unicodes, I think, in C#, but you cannot write some specific ones. But this one, I can even write spaces and hearts. And if I do in some domain modeling with card games, I can put in a heart. I can put the Unicode from the spades and all that stuff. So it depends on. Yes, so if this was a word, but what I'm trying to do is I'm trying to show that, hey, you're actually able to write your type as plain English. I should probably have done it with everything here, but